Hello everyone, welcome back to our channel Math with Lourence. I'm Lourence and today we are diving into a core concept for your IB math journey, composite function. Think about your morning routine. You wake up and you grind some coffee beans and then you brew them. The output of this grinder becomes the input for the coffee. So that means in mathematics exactly what mean the composite function is. First of all, let's talk about the symbol. G of x and f of x. If I have these two functions, and if I want to combine between them, if he write g of f, what mean g of f? This is all actually mean I want to composite between them, or I want to combine between them. So the symbol of combine, that's mean this is O. So he asked me to make composite between G and F. When he wants that, I will start by G and I will substitute each x in J by all of f of x. That's mean I will write f of x inside G of fx. Okay, a little confused, I know that. Just give me 1 minute and everything will be clear. So when he asked me to G of f, mean I will start by J and I will write all of f of x inside each x in J. And also if he say f of g, mean I will start by f and substitute gx inside f. So be careful, those are not same. If I start by j, then I substitute f. It's not same if I start by f and substitute j. How that? Look this exercise, very easy. I have g of x equal x squared and I have f of x equal to x plus 1. First of all, he asked me to find g of f. So I will start by j and I will substitute f. I will write it like that to make it more easy for me. So start by j and between two brackets f of x. What happened here? We say f of x. F of x, that means I delete x and I will write f of x. How? Okay, look. I have g of x is what? Excellent, it's x squared. So I will remove x and I will open two brackets square. Because here I have something square. So I will write something square. What I will write inside this bracket? I will write all of f of x. What is f of x? F of x is 2x plus 1. So I remove x and I write 2x plus 1 inside the bracket. That's good. Excellent. That's mean now everything I solved, I will just simplify and everything will gonna true. So I will repeat, I have g of x equal x squared. I open two bracket square because I will remove x. Okay? So mister, I will remove x. I will remove x and I will write f of x. So 2x plus 1 here. Now let's simplify. To simplify this one, I have 2x plus 1 square. Okay. What I will write? 2x, this is two term inside the bracket square. So the first one square plus 2 times the first one times the second, and also the third one square. Mean 2x square equal 2x, right? Excellent. So 2x square equal 2 square equal 4 and x square equal x square. So 4x square. And we have here 1 and 2x and 2. So I will multiply this is 2 by 1 and also by 2 of x. 2 times 1, excellent, 2. And this is 2 times 2x also equal 4x, excellent. So this is 4x. Now 1 squared equal 1. Because 1 times 1 equal 1. So that's mean when I composite, this is two functions, start from g until f, I will get 4x squared plus 4x plus 1. In another word, I will explain it as a factory. What that's factory? Look, by this factory, if I bring this machine, I have here value of x. This is x. When I get inside f of x, like this machine, is 2x plus 1. I will substitute f of x inside gx. What is gx? Is x squared. So I will delete x and I will insert, this is 2x plus 1 inside it. So this is x, it's converted to 2x plus 1. So it will be 2x plus 1. We have squared, so 2x plus 1 squared. Okay? Excellent. But be careful. It's not enough to composite function and combine between them. It's very important to find or determine the domain of this composite function, because each function have its domain, right? So f have domain and g have domain. When I combine between them, I will have a new domain. So I have to find this is a new domain. Because of that, he say the domain of the composite function f of j is the set of all such that I have two things. First of all, x is the domain of j, and the g of x is the domain of f. Let's see what that means. That means x must be inside the domain of g, so I will get g of x, and g of x inside f, I will get f of gx. Okay? Mr. Explain more. Okay, another word. X inside j, I will get g of x. G of x inside f, I will get f of gx. That means this is x. When I composite, I will get f of g of x. Can I see it by exercise? Okay, it will be more easy by exercise. Enough explain. Look, I will solve at least 10 exercises. So this is the video. Each exercise after I solve it, please, when you restart this video and the study, just stop this video in all of this exercise and solve it again to practice more. So find each composite function, determine the domain of each composite function. First of all, f of x equal to x minus 3, g of x equal x plus 1. So what you want? He asked me to find f of j. Okay. That's me, Mr. f of j. I will start, okay, and domain also. First of all, f of j, that's mean I will start by f and substitute j. Let's start by f. Mr. f is 2x minus 3. But I will remove x and I will write g of x. So I will start by f, I will remove x and I will write g of x. Mr. What is g of x? G of x is x plus 1. Excellent. That's it. So I will write x plus 1. So remove x, write g of x. I will substitute g of x. G of x is x plus 1. Okay, that's it. That's it. You will just simplify. Let's simplify. Here I will multiply 2 times x, 2x. And 2 times 1, 2. We have negative 3. Okay. 2x, it will just keep 2x. Positive 2, negative 3 equal negative 1. Excellent. So the composite function is 2x minus 1. Mister, you didn't find the domain. Okay, look. The first one, f of x, is first degree. First degree means start from negative infinity until positive infinity. All of R, it's okay for x if you substitute it. Okay. And g of x, also all of R, start of a real number, start from negative infinity until positive infinity. Okay. This is R and this is R. If I combine between R and R, what I will get? R, excellent. because this is our all real number and our all real number. So if I combine between all real number, I will get all real number. So that means that the domain of these two function is started from negative infinity until positive infinity, mean all of R. Excellent. The first one R, the second one R. I will combine between R and R. I will get also R. Excellent. Well, another exercise. If I have f of x equal x minus 3 and g of x equal x squared plus 1, and he asked me to find g of f, I will start by g and substitute f. Excellent. Good. So I will write g between bracket f of x. Okay, mister, let's start by g. X squared. I will remove x and write f. Plus 1 plus 1. Okay. What is f of x? F of x is x minus 3. Excellent. So I will write x minus 3 squared. Now, x minus 3 squared, this is, I can simplify it by write this one squared. X squared is x squared. 2 times 3, 6 times x, 6x. And 3 squared equal 9. Plus 1 plus 1. Now, what can I do here? X squared, I don't have anything square. 6x, I don't have any x. But here I have number with number. Positive 9, positive 1 equal positive 10. So that's it? Yeah, that's it. Who can tell me what is the domain here? Excellent. The first one is first degree. That means all of R. And also here is second degree. That means all of R. So I will combine between R and R. What I will get? Excellent, R also. So the domain will be also R start from negative infinity until positive infinity. Excellent. Here we have fraction. Fraction, this is another situation, and the square root, another situation. So here we have three situations. First one, the first and second degree, it's easy. And also this one easy, but it have little trick. So we have to be careful when we deal with a fraction. So f of x equal 2 over x minus 3. And g of x equal 1 over x. He asked me to find f of j. That means I will start by f and substitute g of x. What is f? Is 2 over x minus 3. Mister, I will remove x here and write g of x. Okay. So 2 over gx minus 3. What is g of x? G of x is 1 over x. Okay, that's it. So I write 1 over x. I will repeat. 2 over x minus 3. I will substitute x by g of x. Okay, I will write g of x. What is g of x? Is 1 over x. So I write 1 over x. Now 2 over 1 over x minus 3. What I have to do here, I will make it same denominator. Excellent. So here I will multiply by 3. It equals 1 minus 3x over x. 1 minus 3 over x. Where is the x? Because we have in denominator, I will take it for numerator. Because I have fraction over fraction. So I will take, this is the last one. I will remove it to by reciprocal to the numerator. Excellent. So 2x over 1 minus 3x. Good. That's it. That's it. I have to do another thing? No, that's it. You just compose it. So we just here substitute g of x and we make here the operation. We just make it same denominator and we remove x to numerator. Now, mister, you have to determine the domain. Yeah, look. When you want to determine the domain in a fraction, you will find it directly before you simplify, be careful. When you want to find or determine any domain for composite function, you will find the domain directly after the first step, not after simplify, because when you simplify, everything will be changed. Here I have 2 over g of x minus 3. Because this one, it not should be equal 0, because I don't have any fraction equal 0. That means x here, or g of x, all of this value here, it should not be equal 3, because 3 minus 3 equal 0. But Mr., you talk here about g of x. We didn't substitute it yet. Yeah, excellent. So we will start here. Here we didn't substitute it yet. So I will start here by 1 over x minus 3. 1 over x minus 3 should be not equal 0. By reciprocal, take 3 to another side. By reciprocal, I will get x not equal 1 over 3. And also here we have the gx is 1 over x should not equal 0. Because here x it shouldn't be equal 0. That means x should be not equal 0. Mister, that means we have here two situations. Yeah. So two conditions. X not equal 0. And also x not equal third. So that means what is the domain? That means all of R except 0 and third. How can I write it? I can write all of R except 0 and third, or I can write it actually. Start from negative infinity until 0, from 0 until third, from third until positive infinity. So, Mister, here I'm a little confused. Yeah, I know. But be careful. I will just repeat it by the last line. We have here g of x should be not equal 0. And that's it, 1 over x. 1 over x should not equal 0. And also should not equal 3. Why, Mister? Because 1 over x minus 3. If this one equals 3, okay, that means 3 minus 3 equals 0. And 2 over 0. Is it right? No, because I don't have any number over 0. 2 over 0, that's impossible. Okay? So that's undefined situation. Because of that, this one should not equal 0. I will take 3 to another side. By reciprocal, x not equal third. And also here, the g of x should be not equal 0. That means x not equal 0. So when I combine between them, that means all of R except 0 and third. So that means start from negative infinity until 0. From 0 until third, from third until positive infinity. Okay? Excellent. Mister, another exercise. Okay. F of x, 2 over x, g of x equal 1 over x. He asked me to find and combine between g and f. Start by j and substitute f. Okay, what is j? Is 1 over x. I will remove x and I will write what? F of x. This is f of x. The f of x is 2 over x. So 2 over x should not equal 0. By reciprocal, x over 2 not equal 0 means x not equal 0. This is first condition. We have another one maybe. Let's see. I will start substitute. F of x is 2 over x. We have fraction. And in the denominator we have a fraction. So by reciprocal, I will remove x to numerator. So it will become here x times 1 is x. So x over 2. Okay? Here we have any condition? No, mister. Why we don't have any condition? Because here in the denominator we have number, we don't have x. So this is not fraction. In the denominator we have x. So that's mean this is only the condition 2 over x, x not equal 0. That's mean the domain is all R except 0. We can write all R except 0, or we can write start from negative infinity until 0, and also from 0 until positive infinity. Deal? Deal. Excellent. Well, another exercise. Find and then evaluate each composite function. Oh my God, here we have square root. So this is the third condition we have. Okay, so let's say the third situation. F of x equal root of x, g of x equal x minus 2. He asked me to find f of j. F of j, that means I will combine f and j. Then I will substitute 6 by the last composite function I have. So f of x equal root of x. He asked me to find f of g. So I will start by f. Let's start by f and substitute gx. F is root of x. So I will remove x and I will write g of x. Okay, that's it. What is g of x? Excellent. It's x negative 2. So x minus 2. So that will be root of x minus 2. Mister, what is the domain of x minus 2 under the root? Oh, this is a good question. When I have any square root, I will ask myself the first question. Is there any square root for negative number in real number? Root of negative 1, I don't have root of negative 1. Root of negative 2, no. Root or square root of negative 3, it's impossible. So, but I have root of 0, yeah. Root of 1, 1. Root of 2, okay. Root of 4 is 2. Root of 9 is 3. So I have square root for positive and 0, but I don't have it for negative. Because of that, this one should be only 0 or positive. So root of x minus 2. If I substitute x by 0, 0 negative 2, oh, negative 2. Let's write 1 here. So 1 minus 2 equal minus 1. So also still negative. If I write 2, 2 minus 2 equal 0. Okay, so I start by 0. So when x equal 2, that means this is, okay, 2 minus 2 equal root of 0. So that's true. So I will start from 2. If I write 3, 3 minus 2 equal 1. So, okay, 1, I have square root for positive 1. If I write here 3, 3 minus 2, 1, 4 minus 2, 2, 5 minus 2, 3. So all of them are positive. Okay, so that means I will start from 2, because 2 minus 2 equals 0, until all number positive. So start from 2 until positive infinity. That means here the domain will be start from negative, or start from 2 until positive infinity. Deal? Deal. Okay. Now we have to substitute 6 in the composite function. The composite function is root of x minus 2. I will substitute 6 here, so it becomes 6 minus 2 equal 4. What's square root of 4? Excellent, it's 2. So that's mean equal 2. Yeah. Okay, another one. Also here I have fraction and f of x is from first degree and g of x equal x plus 3 over 2. Let's substitute, guys. He asked me to find g of f. So I will start by g, then substitute f. Let's start by g. X plus 3 over 2. I will remove x, so I will write f of x. What is f of x? Is 6x minus 1. Okay, I substitute. Now 6x minus 1 plus 3 equal positive 2. So 6x plus 2 over 2. Here, how can I simplify? I will write this one. Oh, we have a common factor. What is the common factor here? 6, excellent. No, sorry, mister. 2, excellent, yes. So 2 is the common factor. Now I will divide 6 over 2 equal 3, 2 over 2 equal 1. I will cancel out 2 with 2, so I will get 3x plus 1. That is the composite function. Oh, mister, we forget. We have here to substitute 2. Yeah. So let's write here 3 times 2 plus 1. So 3 times 2 plus 1. Oh, mister, I will add first or I will multiply. Yeah, excellent. You multiply first because the multiplication is stronger than the positive and negative. Okay, or addition and subtraction. So 3 times 2 equals 6. 6 plus 1 equals 7. And that's it. Okay? Good job. By the end of this video, I hope if I help you to understand everything about composite function. If you have any question, you can send it directly to our platform, Math with Lourence. You can find the link in the description. Have a nice day.